Okay, please turn your attention to this sheet. This is the second piece of content that you have on your final exam. This will obviously also be on your next test, which will be approximately next week, Thursday. This is the second piece of content for your final exam. If you took trigonometry and you did not know how to solve right triangles, some people would say you never learned trigonometry then. Okay, it's that essential of a skill. Good news for you, most of you have already learned a little bit of this before. So let's go to work. Sine is written as y over r. You may remember that. Cosine is written as x over r, and tangent is written as y over x. But the fact is, in real life, we don't often talk about x and y. Rather, we talk about sides of a triangle and their relationship to the angle. Let us come up with some new words. What is the longest side of a triangle called? Hypotenuse. Now, if you look, every time we talk about an angle in the triangle, the angle is made up of two sides. One side will be the hypotenuse, the other will be the side next to the angle. So for example, if I say that Luke is sitting adjacent to Jesse, that means he's sitting next to Jesse, right? Adjacent means next to. So this is the adjacent side because it's next to the angle. Hypotenuse is the longest leg. Adjacent is the other one that makes up the angle. Does anybody know our third side? We call it opposite. Anybody want to guess why we call it the opposite side? Exactly, and I think that that's the easiest one to identify. I always start by identifying the opposite side and the hypotenuse, and I just say the other one is the adjacent. So opposite is directly across. So now we could change our meanings. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And we'll get to that. Anybody want to make a suggestion for what tangent would be then? Opposite over adjacent. Good. So I never learned the saying that I'm going to show you right now until I started teaching. Actually, I was tutoring a friend, and I always just did X, Y, and R. I always said this is Y because it goes up and down, this is X because it goes across, and this is R because it's the radius in a circle. That's all I ever did growing up. My friend did this. She said SOHCAHTOA. And to me, it sounded like a word from a different language. I thought it meant something in like Native American language. I was like, what are you talking about? She's like, SOHCAHTOA. It's what we do for sine, cosine, tangent. I was like, I have no idea what you're talking about. What this says is that sine is the opposite divided by the hypotenuse. It says that cosine is the adjacent divided by the hypotenuse. And it says that tangent is the opposite divided by the adjacent. Still to this day, I don't really think about SOHCAHTOA unless I'm teaching. I still always go back to X, Y, and R. I just like them a lot. SOHCAHTOA, you learned it before in geometry, correct? It's part of our standards. If you didn't learn it, you weren't paying attention. Let's go. It says find the exact value of 6 trigonometric functions for theta given the legs of the triangle are 15 and 8. We're going to call them 15 and 8. Okay? Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Nope, not today. So we're going to call this theta right here. Which leg would be 15 and which would be 8? What do you think? Will 8 be the tall one and 15 be the longer one? So if I want to write an expression for sine, sine is what in terms of opposite, adjacent, and hypotenuse? What is sine? Opposite over hypotenuse. Do we know the hypotenuse yet? What will we do to find the hypotenuse if this is a right triangle? Pythagorean theorem. Pythagorean theorem says 8 squared plus 15 squared is equal to, I'll call that c squared. Or 64 plus 225 is equal to c squared. Or 289 plus, or is equal to c squared. They know the square root of 289? 17. So, can you give me a ratio for sine? A ratio for sine. What is my opposite side? 8. What is my hypotenuse? 17. So sine will be 8 over 17. Cosine in terms of opposite and adjacent and hypotenuse is adjacent over hypotenuse. What's your adjacent side? 15 over hypotenuse, which is 17. In terms of opposite, adjacent, hypotenuse, what is tangent? Opposite side is 8, adjacent is 15. Now, Haley asked about writing information down for this side on the previous page. I don't bother because all we have to do is, what do we do with this number to get that number? Reciprocal. Okay, I would like you to flip to example 5. We have fewer days this quarter, and so there's some parts of the notes I have to skip in order for us to finish on time. We're behind by about 3 days. Not that we're slower, but we just have 6 less days this quarter than what I did last time. So just the way the schedule fell. So we're going to kind of skip around a little bit. It says solve for the missing side of the triangle. You have to have your calculator, and we are going to go to work with this piece. I want to be able to find x. Can you tell me, is 9, if this angle right here is 42, is this the opposite, the adjacent, or the hypotenuse? This is the opposite. How about x? Is x the opposite, adjacent, or hypotenuse? Hypotenuse. So what I'm going to teach you how to do now is find a missing side of the triangle. If I have the opposite and the hypotenuse, will I use sine, cosine, or tangent? Which one involves opposite and hypotenuse? Sine. So that's where you have to think of SOHCAHTOA. I have the opposite and the hypotenuse, and so I use sine. See it now? Okay, all right. Unless you say something, I assume you see it, so let me know. So I take the sine of the angle, 42 degrees, and I set it equal to, what is the opposite? 9 divided by, what's the hypotenuse? X. And I always cross multiply. What is 1 times 9? 9 equals the sine of 42 times x. How will I solve for x? Divide by the sine of 42. So I'll take my calculator. Should I be working in radians or should I be working in degrees? Degrees. I go to mode, I go down, I select degrees. Anytime you're solving right triangles, you will always be in degrees. And I take 9 and I divide it by the sine of 42. You can see that I get 13.45. Does it make sense that x is bigger than 9? Why? Because it's the hypotenuse. Let's try another one together, and you guys can try one on your own. This angle is 63 degrees. Tell me, which side is 14? The opposite, adjacent, or hypotenuse? Hypotenuse. How about x? X is the adjacent. So, Bergen's going to help us out here because he had the light bulb go off earlier. If we have the adjacent and the hypotenuse, will I use sine, cosine, or tangent? Adjacent and hypotenuse. There it is. So I have the cosine of 63 degrees is equal to, is it adjacent over hypotenuse or hypotenuse over adjacent? Adjacent over hypotenuse. So x over 14. Always write it over 1 and cross multiply. X times 1, x. 14 times the cosine of 63 degrees. So I go to my calculator. I take 14 times the cosine of 63. And I get 6.36. We will round to the nearest hundredth for this assignment. Here's the right angle. I want you to try this next one on your own. You can do it. I believe in you. If you write that, what is 9.4 times the tangent of 27? What'd you get? What? 4.79. Does it make sense that it's smaller than 9.4? Yes. So we pause here. Here we go. This is what you're going to have to be able to do for the test. Use sine, cosine, and tangent in order to solve right triangles. First thing I do is I make my 90-degree angle. C is always the 90-degree angle. I'm going to choose this to be A. I'm going to choose this to be B. In this case, it tells me that angle B is 32 degrees. Now follow this closely. If you don't get this, you can't do the problem. I have big A, big B, and big C. Those are the angles. Little a, little b, and little c are the sides. They will be opposite their angle. So this is little c, this is little b, and this is little a. It will always be like that. See that? Is that consistent with what you did in geometry? Yes. To solve the triangle means you can fill out this whole piece right here, all 6 of these. What side do we know? What side are we given? C is 8. So let's start writing things down. Do we know angle A? Nope. Do we know angle B? Do you know angle C? You know side A, side B, side C. If you don't write those 3 down, you're not trying hard enough. It tells you the information right there. Furthermore, if you don't get this next one, you're not trying hard enough. All the angles of a triangle must add up to what? 180. So can I figure out angle A pretty easily? Very easily. So let's figure out angle A. We'll take 180 minus 90 minus 32, and I get 58. Hey, what do you know? I got 4 out of the 6. I just need 2 more. Would you, Maddie, like to figure out angle B or side A? You choose. Doesn't matter. You can't be wrong unless you choose C, because we already know it. You like to know A. Awesome. We're going to find A. We're going to find A, and we know side C. Tell me, will I use sine, cosine, or tangent? This is the hypotenuse. This is the opposite. This is the adjacent. She wants to find A, and we know the hypotenuse. Sine, cosine, or tangent? Cosine. Why, Maddie? Adjacent and hypotenuse. So for ka, toa, adjacent and hypotenuse. So let's set up cosine. The cosine of what? What's my angle? 32 degrees is equal to, what's the adjacent? A over 8. Cosine of 32 over 1. Let's cross multiply. 8, A is equal to 8 times the cosine of 32 degrees. 8 cosine 32. 6.78. Does it make sense that A is smaller than C? Yeah, it does. Why? Because what's the biggest side? C. Now, I want to find B. What could I do to find B? The Pythagorean theorem. The Pythagorean theorem says 6.78 squared plus B squared is equal to 8 squared. Or B squared is equal to 8 squared minus 6.78 squared. So I'll do that on my calculator. 8 squared minus 6.78 squared. Is that my answer? What do you have to do? Take the square root of it. And I get 4.25. Finally, look at this right here. What's the biggest angle? 90. What's the biggest side? See how the biggest angle goes with the biggest side? What's the smallest angle? B. What's the smallest side? B. And then the middle, A and A. So tomorrow, we'll continue to work on this, solving for right triangles. We'll do another example. We'll do problem 1 together. But if you want to try one on your own, you would hopefully come to class well prepared then. I will not give you a new assignment tomorrow. This is what we're going to work on, okay? But this is essential, essential.